Alright everybody, welcome back to another update. Yesterday's update did discuss the Central Plains in Oklahoma and North Texas with the enhanced risk. And there were a few tornadoes that did occur in that overnight period into the early morning period. A lot of chasers were in that early morning period streaming the outbreak of mainly the MCS that went through, and so there was a lot of MCS based tornadoes, quick spin up tornadoes that did occur. Somewhere like Lewistown, Texas, if I'm correct, and Ada, and there was certain tornadoes that did cause some significant damage, potentially up to high-end EF2 equivalent damage that is yet to be determined by the NWS in the local region. As of today, we have an enhanced risk within the southeastern part of Oklahoma, northeastern Texas, part of that same MCS system that's persisting through, which is why you have this very sharp gradient of the risk zone on the western side. And then you have the southern Arkansas now with a bit of a northward extent, and you have a little bit of a removal from this southwestern extent. Instead, we have now northern to eastern Louisiana, southern Arkansas, central to southern Mississippi, and southern and slightly central Alabama, with the Florida Panhandle now included as well. With that mainly due to that QLCS, MCS, more so a QLCS type system that will move all the way through and produce significant gusts. But then the main tornado threat will be likely, as we'll be discussing, potentially in the southern Mississippi to southwestern Alabama. Could be the most favored corridor, even in the far eastern Louisiana, that could be the favored corridor. And so as of now, we've got a large 10% SIG-TOR region, which is basically the hatched region where 25 miles of any given point there's 10 to 14% chance of a significant EF2 equivalent tornado occurring within that specified zone. And we have a larger at 5%, which is mainly encompassing any QLCS type threat, and anything up here in this northern part near Arkansas is more cold core in nature, with the way the 500 millibar upper level low will be close to the surface level low, and there'll be that cold air that will act as a way of instability to create a cold core setup for increased tornado potential. We have this significant wind threat now with the hatch, which will suggest winds of over 75 miles per hour. Significant gusts are possible, and it could occur slightly out of this zone potentially should it mature anywhere else. But most favoured corridor is within this region, and that's largely where the storm mode will favour large QLCS, and those will produce damaging gusts. And now those damaging gusts are usually caused from certain things, where there is strong updrafts and downdrafts, and within the system you have this line echo wave pattern, which is like a wavy sort of bow-shaped pattern that is exhibited from a QLCS type system. And in those you have strong individual downdrafts that can bow out and really produce the strongest winds. And often you can even get downbursts in those regions as well, which is where that really high precipitation, so often strong winds, can also occur. Then we have a largely no real significant hail threat, so that's not really the main concern here. And then there is a day 2 which we'll be discussing tomorrow, but as of yet I was expecting the enhanced risk, and we do have it. It's not so much as tornado related as for wind, but there is largely has been upgraded, and it could increase that tornado risk to potentially a 10 unhatched risk here as well, because there is still that favoured corridor as compared to that 23rd and 24th 2016 outbreak that did produce several significant tornadoes in this very similar type of environment that we'll be looking into tomorrow. But then for today, looking at the SPC discussions at the moment, we do have some discussions currently that says water vapor imagery shows a large-scale mid to upper level trough moving east across the central and southern high plains this morning. Several embedded perturbations are rotating through the large-scale upper feature. The most notable feature bringing a 100 plus knot, 500 speed max to move over south central Texas to lower Mississippi Valley, Tennessee Valley, mid-south, and with the steepening surface low will move from Kansas to mid-Mississippi Valley during the period as cold front sweeps across the central Gulf Coast. And then we have the squall line mention, and we have intense wind shear profiles with an adequately unstable sector, and we have, which has improved more so than yesterday's model runs, favour severe gusts, and we have that risk of a few tornadoes, and we have some mentions of large hodographs supporting storm scale rotation. Ahead of the squall line will be very important to watch out for. And then we have that strong tornado potential in the diurnals during that later period, where diurnals destabilization and northward returning Gulf moisture will aid in storm intensity coverage. And then it will maintain likely a linear mode as well. And so with that, let's look into that. Alright, today we're just going to look at the trough geometry as well, including the trough evolution, because it'll be very important to just discuss this as we're looking into it. So by 0Z and 21Z, we can see that evolution. So currently where we are, we've got this maturing trough, and clearly a lot of the winds currently are on the base of the trough, more so on the western side, and it's translating and quickly speeding up to the east. And often when you have that increased severe potential and that large scale ascent, you're going to have that speed max move and evolve very quickly across to the eastern side and eject into that region where the most severe storms will initiate to get that very significant outbreak. And we're starting to see that come into fruition, and by 21Z we do see that speed maximum here of 100 plus knots, upwards of 120 knots even, and that will push through the region. And that will be just about entering Louisiana. We see those southwesterlies and slightly more due southerlies, and we see like this area where there will be like a defluence, and that will allow for the air parcels to rise through the lower levels of the atmosphere, converging in the lower levels, and then diverging in the upper levels. And we will see largely with this sort of behavior with wind directions, mostly a linear threat, and some of the linear system currently may persist through, but we'll largely see a new initiation of convection from this system as it evolves eastward. And so where somewhere in this central region of Louisiana, there is this slight perpendicularity compared to the northern extent, where it will favour more so. When you have this perpendicularity, you have the air parcels less likely to collide into each other as it's you're less likely to have air parcels to form updrafts that converge and collide into each other, creating a messy squall line type system. But you're more likely to have a supercellular structure, because you're going to have these individual updrafts that grow and become isolated and can develop into these mature rotating updrafts that become supercells, and those can eventually reach the lower levels to produce those significant threats that has been highlighted. And as of yet, we see this neutral to slightly negatively tilted troughing, and then we will see that evolve by 0Z to that strong negatively tilted. And there will be a slight concern with how eastwards the progression of this jet max is compared to the dew points and where the storms initiate. Should those storms move slightly, be slightly behind, or slightly by the time it reaches into this more favourable zone, it might already be a QLCS. So again, the surface pattern is important to recognise in case there will be potential out in front of the line sort of confluence boundaries, and those boundaries are ahead of the line. Typically, they allow for these subtle convergence where you normally have like a southwesterly wind and like a southerly wind. Those converge, allowing for air parcels to rise and create updrafts ahead of the line, and those updrafts can become supercells isolated and in front of the line, which have the best access to the moisture and can utilize the low level jet by that point, which will favor tornadic potential. And so we're going to look at the surface patterns here as well. And so by this point, you will see a large surface low that is located around this region in northeastern Oklahoma, southeastern Kansas, and then you'll see it progress as well and then deepen. There is clearly a lot of these isobars are very stacked within this region and here that will favour the strong winds, but also a strengthening surface low that will provide. It will become a strengthening surface low, which will also allow for the system to mature, and the back surface winds will increase the surface moisture that will advect northward. And then we see the dew points. We have this carving, which is where essentially the MCS systems will already be. So by this point, you already see these storms already initiate, especially in the northern extent, being pinched off that warm sector. And a very narrow warm sector. It's not as much of a V shape. It's now a little bit more broadened out. That will slightly increase the warm sector width, which was previously discussed yesterday as a very short width and a very narrow pinched. But now we have this access of rich moisture to southern extent, and we also have these storms that could initiate out ahead that could move eastwards and not necessarily be affected by these northern storms should they be in the southern part of the sector moving across where the more significant threat is likely. And we still see 60 dew points and increased dew point values as compared to yesterday, so that could be an important factor as well in determining the strength of and growth of the updraft. And so we can see a low level jet persist. You'll see this strong, almost, well, really high actually, almost above 70 to 80 knots of a low level jet that will persist. And even in some spots there's 90 knots, which is just insane to me, really. But there is really high values in general that are forecasted to exist with this deepening surface low. And also with the low-level jet, what I've learned and what I've understood is that it's by a geostrophic flow. So that's the flow that's not necessary. That's not more necessarily by the environment and the ambient environment itself. And so when you have an ageostrophic flow, and they have this ageostrophic vertical circulation, where in the diurnal cycle, where the sun rises, heats the atmosphere, and then it sets and it cools down. In that diurnal cycle between that day and night, during that transition, you tend to have cooler air going towards the nighttime period, and then that allows for the rising of the winds into the low level jet, where the winds become more laminar flowed, and you also tend to have this circulation that allows for the strengthening of those winds on top of what already the low pressure system deepening is already providing, which provides extra to the low level jet wind shear. And so you may have regional maximums that occur within these areas like you have here, and that tends to be the reason why that happens. And I do not fully know the entire explanation, but the research is there that I've researched about. By what is difficult to realize, but you have your sort of more dry line, pseudo dry line here set up here. That's your region where it will be set up, but then you also have this sort of zone where the winds change also ahead as well, and that's likely where like confluence boundaries could occur. And you also even have some pressure, like these little pressure like this inversion here with this pressure isobars, and this is where the other confluence boundaries can occur. And so you also even have like these southerly winds and these southwesterly that I was mentioning. So again, it could be where these storms initiate, and it is generally overlapped with, and it is generally overlapped with the region in which the strongest wind shear, low level jet wind shear is. It will tend to be slightly on the weaker side, like compared to where the strongest and most favoured is. But still, regardless, it is still in a very favourable location where these storms will occur and propagate eastward. So even in the QLCS system, there will likely be this favourable low level jet that will enhance QLCS tornado potential as well. And we might see that really extensive convective QLTS initiation, and it might actually convectively enhance like the shortwave troughs that may potentially occur within this region, and so that might add to the messiness by adding more convection into a linear mode. So like looking into 21Z, so if we just do it here, and then we do up here, maybe like where the QLTS system will persist, and potentially upwards here as well, up here as well, where we can see that cold core setup occur. So this is in that favored region that was previously mentioned, and it really is still an example of how the potential still remains for significant severe weather should those storms initiate, especially when you look at it from like a perspective or just the bulk shear values alone. We have 73 knots, and there's even in the surface 1 kilometer we have very strong SRH values, where essentially low levels you have a lot of that area covered, suggesting a lot of that speed shear and wind shear, in directional wind shear change, with that 10 knot, almost 20 knots to like 10-15 knots to almost 50, 60, 70, just within that 1,000 to 800, probably not even 850, 900 millibars. So a very quick change, and that's demonstrated by this hodograph as well, with this in the 0 to 3 kilometer part of the hodograph, a lot of changing and veering of the winds and strength with the height. And you'll also see this backing as well, that could allow for a good ventilation and allowing for those updrafts to maintain, and mesocyclones to not necessarily occlude and dissipate, but allow for the ventilations of those updrafts and those systems, so they can persist for longer periods and become more long tracked. And then we also have that pretty significant outside of what the hodograph can register outflow, upper level outflow, which will help for the venting of precipitation, but also will allow for that visibility to increase should you observe the storm. And that would be slightly unusual compared to the typical eye when observing these severe events in Dixie Alley. And we even see a very significant storm relative inflow here, a very significant 10, almost 40 plus knots here, and that will allow for very strong ingestion of this low level shear. And we have effective inflow layer of 635 meters squared per second squared, very significant amounts, kind of demonstrative why the PDS tornado is demonstrated here, but it's really what will provide more so than the instability values the thermodynamic profile will provide, because this is much higher than what it will typically occur in normal setup, should I say. But looking at the thermodynamic profile, despite any contamination, you will see here a lot of this instability is now you don't see any inversion, you don't see any sort of EML is remaining here. You see a very rich moisture that extends very deep above 850 millibars, which is essentially where you'll have that significant moisture, allowing for the buoyancy of the air particles to rise and strengthen into a very strong growing updraft. And that instability will help aid in that system, in the updrafts developing all the way up, and allow for the ecotops to shoot very rapidly into the air, allowing for that strengthening supercellular potential at 1,536 joules per kilogram mixed layer CAPE, which is an adequate amount compared to the 1,000 joules per kilogram normally. That is just enough for these larger supercells for them to maintain and persist. We have low LCLs matched with this, and that will allow for this low bases to lie, allowing for that vorticity, particularly in the 3 CAPE. We have almost 130 joules per kilogram 3 CAPE, which is very, very significant values, almost 2.5 times more than what you need. With the lowest LCL should match with this very efficient tilting and stretching of vorticity, this rotation that will occur and be already existent in the ambient environment with that low level shear and a low level jet in place. allowing for that vorticity to be stretched and tilted in the vertical. Any sort of large condensation and like potential strong tornadoes could become fairly large sized and could persist for a long period of time should they supercells occur in the head of the QLCS line. And then we also have a severe threat with not much precipitation because of how fast the forward speed progression is likely to be, where 50, 60 miles per hour translational speed will mean that they don't persist in the same region for a very long period of time. So that will prevent that precipitation amount from being very high. And we also, what you can look at is the storm relative inflow and compare it to a perpendicular a vector, and that will determine typically where how much streamwiseness of the streamwise vorticity current that exists within the supercellular systems that normally aids in the tornado genesis phase. It's this flow that acts as a way to increase that rotation, that very surface level, like in a very immediate short period of time within that where the tornado normally occurs and condensates to the ground. Acts as a very significant factor. And when you have a perpendicularity with that vector and it's very parallel to this storm relative inflow vector, then that tends to mean high streamwise vorticity currents within the supercell, and it will ingest that, and it will allow for that the tornadogenesis to occur. And we see that, should you draw a line here. And the overall a very good profile to demonstrate what's going on. And here we actually have almost a ridiculous wind shear graph that doesn't appear on the screen. This is in that northeastern quadrant where the QLCS actually will be. So again, despite any sort of unusual phenomena or or at least a messy linear mode, because you have you will see this sort of parallel vector occurring pretty parallel with the initiating line, the dry line region. You will still see a very strong wind shear, and kinks will occur within that line now because of this very significant low level shear that's already present, almost 1,105 meters squared per second squared effective inflow layer. Very, very significant values. And the one thing will be that might slightly wane the potential will be that slightly reduced mixed layer CAPE value of only 900 joules per kilogram. But regardless of this kinematic profile matters much more, because that line will already persist and will take advantage of what daytime heating will already provide previously in the sector, in the region to the west where it already initiated. And we see this slight warm nose, but that should not matter either too much given this profile, because it just is such an extreme profile that it almost always will compensate for like if there was at least some other more moderate values from the thermodynamic perspective. And then we see here a cold core setup, so we see very minimal, at least from this sounding here, very minimal instability. I feel there is a bias here where the instability could be easily double this value, and then you will see 3 CAPE and a very significant percentage of that total instability value still shows if you have any mini supercells that will persist with this sort of value of lower instability, and despite moderate, very low wind shear values and storm relative inflow is only 80 meters squared per second squared. That doesn't really matter because of this significant cold setup where it provide instability for tornadogenesis to occur as well. And we see a significant varying of that wind as well around the surface low pressure, where you have those along the triple point. You have that vorticity that is provided extra by the surface low pressure itself, translating west to east. And then I think that's everything that's largely had to be said about the actual dynamics currently to be said, to occur. So with the HRRR, just to review what it will show. Yeah, as of yet, it still does not show in this run like that significant tornado potential, even but maybe upwards. Once you get to 22Z, you start seeing these updrafts in the southern extent in this broken sort of line, but then you have this very significant line of QLCS that could be significant potential as well, and strong winds. But again, it's this period between 21Z to 1Z where you will see that this very favoured corridor, and even still upwards of just 2Z, you will still see that potential in the very southern region along the coast. And then you'll see on the cold core setup, not all too much happening. Maybe some systems out ahead and along this line, but that line will fade eventually. The line of fading can normally occur when there is significant downdrafts that can affect the ability for the QLCS to actually it provides a very significant cold pool that will reduce that overall instability and the winds that can push the line ahead, so it weakens dramatically and it tends to fade away, as in you'll see in simulated roof activity the values decrease on the northern extent, and then you see the QLCS much stronger and strengthening where it initiates out west and northern Louisiana and moving east, and then that will persist all the way out even into the Gulf Coast. You can see it, and you can see that little surface low up there as well. With this, I think this is everything I had to say with this update. There probably are some things I did forget and are not clear enough, so if there is anything like that, please do mention it in the comment section. We all do make some mistakes, and I kind of want to learn as well. So with that, I will see you guys in tomorrow's update.